Good afternoon. So I'm here to talk about AICE security, which is the new evolution and solution for AI security. These days, in many of the businesses, a lot of activities are done using AI, and there are a lot of multiple approaches towards AI, and the security sector is no exception. A lot of challenges have been made towards AI. So let's take a look at how it's evolving and how A security is responding to the trend with what technologies. Maybe you have not heard of my company name, A Security. Up until the first half of this year, we focused on technology development, and starting from the second half, we are doing and we are going to do a lot of marketing and sales. So we are a quite new company. So we have references in some communication companies and public corporations, but starting next year, we will push ourselves even more to create more case studies to come back to you. So think about the fourth in this revolution. So some of the keywords include hyperconnectivity, hyperconvergence, and hyperintelligence. So these are the technologies that are commonly mentioned in Industry 4.0. In fact, many of the companies around the world work around big data, cloud, IoT, and so forth. So they use technologies to have them applied to their business because their competitiveness actually is pretty much determined by these technologies. But when you think of hyperconnectivity, it is actually intended to connect everything on the internet, or the network. So it is very likely to be exposed to intrusion attacks. So it seems like the doors are quite open to such threats. And also for hyperintelligence, AI is used to overcome any of the limitations and also to bypass many of the restrictions against threats. There are a lot of intrusion instances. There are about 25% of the intrusion incidents in Korea. So it's quite high in the global ranking. And if you think about the DDoS, so there has been an attack worth 385 million packets. So there are clouds attacking for targeted threats, with targeted threats. So VPN accounts are stolen and which are easily traded in dark web. So you can see that as industries are more intelligent and converged and connected, there is an increasing amount of security threats as a result. And actually, you saw how the vehicle was launched, Nuriho, yesterday. In order to excavate more data, maybe a lot of threats are being explored now around the world. So, in that sense, these three keywords in Industry 4.0 are critical. Why do I mention this? Because these are critical on the attack side, but also these are critical on the defense perspective. Because connected network and hyper intelligence and convergence are very key, very much pretty keywords for defense. So how would AI and security have been evolving, and how should they evolve forward in the future? As for AI, up until 80s, it was not spotlighted a lot in the IT field. So maybe in sci-fi or sci-fi novels or movies, AI was mentioned to a certain degree. So AI actually was for the first time in 1956 by John McCarthy, and up until 80, it was like an AI winter where there was no technological progress on AI. As for security, so we just thought of PC virus or vaccines during this period. However, moving on to the 90s, there came to be some changes in AI. There was announcement of Deep Blue from IBM. So Actually, there was this AI winning a person over a chess game, and from then on, internet developed so much, and Korea is #1 in terms of internet penetration. So thanks to the spread of internet usage, there actually came into being a lot of attacks intruding into firewalls. So actually, firewalls actually are the ones where many of the attacks are penetrating into. And moving on to 2000 onwards, actually a lot of internet-related attacks came into being. Deep learning came into being in 2006. And also Watson of IBM in 2010 won over a person in quiz show. So you can see that there are different types of attacks and corresponding responses like IPS. And also technologies for circuitry response against attacks came into being. In 2016, there was something dramatic. Before 2016, the field of AI was rather a field exclusive to people who are involved in technologies, not for everybody else. But AlphaGo was made by Google, and AlphaGo actually won in the Korean chess game or Go game over this Korea's #1 Go player, Isidore. So actually, unlike chess, Go was a match or a game where human beings cannot be defeated. But in Google, 300,000 probabilities were injected into the AI to overcome the hurdles to win at the end. So that was a trigger for everybody to be interested in AI. And in fact, in many of the businesses, there have been applications and related attempts for using AI. And security is no exception. And since then, even without using CPU, GPU, AI exclusive chips are being developed. So in deep learning, supervised learning related algorithms were developed. But many expect that unsupervised learning actually will be more of the norm, especially by the year 2030. So in the perspective of security, many of the attack patterns have been modified, increasing so much in scale. And there was a recent attack on the supply chain. There was a targeted attack on IoT thanks to new technologies. And also in terms of AI, by 2030, maybe there will be a complete utopia for AI-driven security. So, what will be the expectations towards AI-driven security? So, there are dozens or hundreds of security solutions equipped by companies at this point in time, but still there are new types of threats, and still these threats actually do penetrate into their systems. And also there are even bypassing attacks coming into the systems. It seems like they would expect that by new solutions, they would be able to better protect themselves. So they wish AI could do the job of being able to predict what's to come, automatically responding, automatically forecasting, and automatically reporting to the managers in charge. So it seems like they have huge expectations towards all of these works on AI. But what about the reality? So given this situation where companies actually want a perfect and convenient operation of the detection by AI. They want everything to be done by AI automatically, but this is not so realistically possible. If you consider many AI-driven security solutions, there are a lot of them in the market, and a lot of R&D efforts are underway as well in the security field. But some of the limitations exist. For example, it has been driven by supervised learning-oriented AI so far, but it doesn't mean that it's wrong. What I'm saying is that most of the solutions are used which are supervised learning based, but still there are some that is based on unsupervised learning. For example, Geunyong, FireEye, these are supervised learning based. But as for the unsupervised one, Vectra, Darktrace, and A-Security, which is a domestic brand, our brand. So cyber kill chain and cyber hunting, and all of the key technological aspects are included. As for cyber kill chain, it is to be able to detect anomalies and the related behaviors, and that's why it's being spotlighted. So what are some problems with supervised learning-based ones, and why is it that some of the problems are being raised here? It's because of the data. The keyword for data is the fact that it is based on algorithms, but still the criticality of data is so high. So without much data, all the AI models would differ. But for supervised learning-based ones, they know the answers, and based on the answers, they are learned as such. But as we bring them to companies, customers, but I mean, would there be a lot of data where the answers are clear and definite? Not really. So that is why it's challenging for AI to learn new things. So that's why it's very difficult to utilize it fully. But for the unsupervised learning-based ones, even with a small amount of data, they can do a good job in doing prediction. So that is why supervised learning-based ones actually are with the answers that are already known, but the latter is more about being able to predict and forecast. So there's this joke in the AI field that as for the supervised learning, so it's like a very expensive private teacher giving you what to answer, right? But then the latter is more like doing some R&D university as professors or researchers. So there's also a lack of technology differentiation in AI security. So AI security experts are needed a lot in many fields, but the number is not so many. So if you look at the material here, I mean, although it's as of 2018, still, not much progress has been made since then. We don't have much labor force here. However, there are a lot of fields, autonomous driving, healthcare, and so many others. You can see that there is a greater demand for AI security manpower. So their value definitely skyrockets. So without AI security experts, companies end up adopting solutions, or they just utilize open source based ones. That's why they don't really feel, for example, the distinguished points for the technologies. They might use TenFlow, applying the open source, just to use AI. So that is why technological differentiation is not so tangible. I know things are not so easy. So there are some hurdles in automation as well. If you are to think about how to utilize AI in the field of security, if there are certain missions that are set, you have to acquire certain data, and these also must be well refined and cleaned before learning. And also there should be labeling of data, and then there is a stage of learning. Actually, if you Google data labeling part-time job on Google, you'll see there are so many job postings. So this means that it's done by human beings. So there's a lot of resource needed. And recently, even for this one, there are other solutions to automate this feature. And also for the job of doing labeling, for example, it's not that easy to find thresholds. So what are the criteria actually for labeling what is being detected? Even if there are criteria, if the number is so many, and And when you do cross comparison, there might be some issues in terms of the performance. So automatic labeling or automatic responses do carry intrinsic vulnerabilities and limitations. As a result, AI is used to reinforce the security features, but then still it's not so easy because this is not yet the mainstream yet. So our research actually have tried very hard to overcome the hurdles. In order to have new platform from AI, what are the things that we need? So what features sure we need? And we came up with 5 keywords. First of all, we definitely have to have AI. So definitely has to support both supervised and unsupervised. We think that unsupervised learning is more critical. And also, cyber kill chain is another critical technological factor to detect anomalies. And not just that, it should be able to process big data. And there should also be automatic labeling and automatic response. So there should be automated operation that is a very critical technological factor in AI. So with all of these keywords, we wanted to make a new AI security platform, and that's why we came with AICE security. So it actually is in pursuit of ATDR platform. ATDR stands for Autonomous Threat Detection and Response. So this is the solution we do seek for. So using AI machine learning, we'd analyze logs and then detect the risks. And also we do detect anomalies as well. In terms of threat detection, there are 2 areas, clustering through unsupervised learning and the kill chain area. These are the 2 ones. So unstructured big data actually can be used that way. You do clustering and kill chain and auto labeling and automatic response. So we actually try to ensure this kind of workflow. Ultimately, through automatic responses, various security tools of our clients can be utilized. I mean, ours are not cure-alls. Our products actually should be able to align with or integrate with other brands to be able to give commands. For example, specifically block specific IP and specific firewalls, for example. And if certain customers are to specifically manage data, and also the correspondent data also must be well exchanged. So these are some technological features of AICE security. There are 4 different categories: being able to collect, analyze, detect, and response. So detailedly, there are just 2 things: how well you can do detection using AI and how well you can do automatic response using AI. If you look at the collection category, there is this survey on inbound and outbound traffic, 100%. We don't specifically filter specific data. So I'll give you more technicalities in the next pages, but we do analyze the entire data for the traffic, and there must be a strong capacity for performance. And let me give you how we do enable that. So AICE actually analyze all sorts of inbound and outbound traffics. So it also would collect the server logs and the security equipment logs and structured and unstructured data. All of these are collected. And also in the field of analysis. So this is when AI starts to be applied. So it is based on the unsupervised learning to be able to detect threats. And also we enable this to detect cyber kill chain-based threats. And the cyber kill chain also gets more sophisticated. And also we extract and continuously update TI or threat intelligence on threat detection threats. And also for detection, let's say AI detects something, and sometimes it's very perplexing. Why is it that it detected it as such? There's not proper explanation, but with our solution, we have AI which can very well explain the why they have detected as threats. I mean, it also generates the threat event identifying detection tools in real time, and this is automatically and periodically updated. And there's also automatic detection rule and automatic labeling, so it's very convenient. In terms of response, in terms of NDR, so it seems like there are more and more events. So for operators, I think it's giving them more work burden. So they're already overloaded, and still there's more events that are coming to overwhelm them. And that is why I would say we fully utilize the automatically responding playbook feature to minimize the workload. And also, this actually can boost the work efficiency because there are repetitive threads. Once these are registered, automatic responses can be enabled. So in terms of operation and management, convenience actually is ensured using a security. So let me give you more details. So I talked about the big data treatment using the standardization. So this is where our technology is most differentiated. So AICE. So the data we generate is actually very compressive, like packet and heterogeneous log, metadata, and numericals, and all the data all can be used for as input data. And also various analytical information can be used as input data from existing solutions where natural language is used. This is not the norm, really. I mean, for other companies, there might be some issues using heterogeneous systems, but we actually have no issue there. We actually do data treatment based on the standardized expressions, and there is a differentiation factor. So we have this technology that was patented in the US. So this can be processed at a higher speed. So there is no filtering of the specific data. So all the data in the packets is analyzed because it's very critical to secure a comprehensive amount of data to be more accurate in detecting machine learning. The other one is clustering is labeling. So you collect heterogeneous data and you do high-speed computation for regular expressions. When these actually go into machine learning, these get clustered. When clustering is done for the first time, then patterns are recognized, and then layer clustering is done, where the clusters are divided. For those that do not belong here, are outliers in AI. So these are kicked off as outliers, and then these actually would go to classification. So we have this TI knowledge database where there is classification, which is clean, which is malicious. So in terms of clustering, so in order to make an initial model, it will take 1 or maybe 3 or 4 weeks in order for the data to be learned. And for the outliers which do not belong to clusters, even the outlier data might be able to be included in the clusters because unsupervised learning actually guarantees that all these data is to be learned continuously. So for the detected ones, it seems like there might be some anomalies, but there's no reaction. But maybe after 1 month, there might be some anomalies happening and they might be included in the clusters. So then you can actually make decision on the threats. So real-time data analysis done based on the model, and the model updates are provided after modifying the clusters. As for auto labeling, so abnormal measures actually can be done of the clusters using distance functions. And also labeling is done in comparison with TI while automatically generating the regular expressions which are equal to each cluster. There's a lot of demand there, so the output must be generated through endless cross comparisons. And then comes abnormal indicator and labeling based scoring to make proper responses. So this is about kill chain. So as for cyber kill chain, there are a lot of solutions that are used, and it's one of the very key technology to detect anomalies. There are 7 different stages for kill chains, but in fact, in the perspective of attackers, there might be the 3 steps: prepare, intrude, and then leak. So as for AICE, we have broken down to 5 different steps. So for each step, responses can be made for a cyber kill chain. First of all, there is reconnaissance stage. So there are certain rules, data to be collected. So there are rules, kill chain rules embedded. We don't just resort to statistical rules. We use AI, and we also have it gone through unsupervised learning to make it more and more sophisticated. So far, I've talked about the perspective detection with our technologies. The biggest feature of AICE is the response feature using playbook, automatic response that is. So if you think of the operators, they are subjected to a lot of repetitive tasks on a day-to-day basis. So on that note, AICE actually has the automatic feature embedded already. So when the data actually is inserted using machine learning, it gets analyzed and it gets detected. So there is matching between response and detection. If you look at our playbook, you can see the IP types of attackers and types of the targets. And there are many other features than these. So all these features actually are made in the workflow. And what is there can be scheduled. So there's repetitive automated work. So these might be aligned with other security solutions. IDS, IPS, APT, and firewalls are aligned with this to give commands to these. By doing that, security managers have less workload and enjoy maximize work efficiency. So when we meet with customers, actually, these are what we have reflected our customer needs on. So there's also automatic generation of dynamic signatures. So as for the known malicious patterns, these can be well detected, but for unknown ones or for novel ones or modified or bypassing ones, these are detected or generated as abnormal behaviors or new malicious patterns. So you can see that there is technological comparison of these different technology features. And ATDR actually was designed to be able to respond to different types of threats. But still, we still lack in the volume for the references. So that could be one weakness at this point. But maybe starting next year, we will be able to have more and more case studies so that I could actually give you actual use cases. And regarding technologies, is one point I'd like to highlight. So there is one unique point with other security technologies. We have unique patents, for example, high-performance big data analytics and supporting various visualization and system alignment. And these were patented in the US. So you can see that there is a continuum of R&D, and we have research papers amounting to 40. So you can see technical requirements are being listened to and are reflected, and also the technologies we have are more and more sophisticated, which makes ourselves very different and special. So let me give you the logical components of AICE security. There are 3 logical configurations: sensors, analysis, and management. So on the sensor layer, as I told you before, a lot of data has been collected, and pre-management is done here, or pre-processing is done here. So the collected data here is moving to analysis layer, where there are a lot of algorithm, kill chain, and machine learning are used for analysis. And in the admin layer, data distribution, visualization, and management are done on the administration layer. So these are the 3 different layers that you see here. But for some customers, they would like to stack up a big amount of data. For example, in order to store packet data, even one daily worth one, you probably would have to require terabytes for storage. So then AICE storage is also made available for them separately. So if you see the components for solution, there are 3-fold. Threat scanner is one, followed by Alarm Advisor and DDoS analyzer. 3 different solutions we offer. So on the network level, as I told you, different types of threats are detected, which is done on the layers of threat scanner and alarm advisor. So web detection is done here, and large amount of big data is also processed here. If there's just so much log, they cannot see it all. And these actually can be grouped, and sometimes this is demanded by some customers. And in terms of the prioritizing security operations, Alarm Advisor would give them tips, and also for AI model for DDoS detection, DDoS analyzer is used for that purpose. These are some of the features of Threat Scanner. I mentioned some of them, so I will skip it. So I'll skip this part. I don't have much time left. So this actually is the main page for detection. So you can see that there are different conditions for search, and also you can have it tagged as well. So you can diversify the conditions. And also, these can be stored in the search conditions. If you do that, you can just bring in the same conditions for the next use. And then you can do the search like that, as follows, and you get a list. And if you go into it in details, you can see the detail pages for specific IPs, the user information and topology information, and threats of threat types. And there might be some charts and the country information where the attack started. And also internally, if you go deeper, you can see even deeper levels of details. And you might wonder, why was it detected? So aside concept, the reason why it was detected is also suggested. The AI does the job. So for this and that reason, it was detected as a threat. So these are some of the screenshots for our solutions. Last but not least, I'd like to give you some tips on how you can utilize our products. I'll give you 3 different case studies. First of all, attacking the vulnerabilities of external VPN. So internal systems look like that, firewalls, servers, and different types of equipment, security equipment, of course. So this kind of attack through internet, the attacker would steal an account, and when they do that, they would use an external open port to access it, to steal the account. And with the stolen account, they would access the servers and do different sorts of intrusion activities. In fact, these do and have occurred. If you can utilize our equipment can be aligned to VPN equipment to collect the logs. So this actually is recognized as anomaly because this is not normal behavior. And even external access to the manager page is not a normal behavior, and it also is detected as an anomaly. So cyber kill chains, account scan, and all the rules actually are used for detection. And all the rules actually used for automatic response in playbook, for example, alarming or different sorts to configure it. And so zombie phishing also can be used here. So infected PCs, for example, when you download something, it can be infected. The PC can be infected. So for the infected PC, the first is to do communication with the C2 server, external one. By doing so, anomalies can actually be detected in the internal server or network. So if a security solutions actually are attached to the backbone, C2 servers can be detected here through the database, and also cyber kill chain can be used. And if external PCs approach it, it is also detected as anomalies. And also it is detected as based on the supervised learning. There was this case where we could actually find that dozens of zombie PCs, even if there were so many security solutions on the school campus. There are a lot of attacks on web server vulnerabilities. So they would come in, utilize the vulnerabilities, and attack is done a lot using the web servers. But information and data is stolen from the database. So here using RTI, attacker ID can be identified, and cyber kill chain exactly the same. So once these are detected, we can actually put an automatic response set in playbook, because this actually cannot be detected in signature ones, but ours is different because web server logs and all of these can be correlatedly analyzed to better detect threats. AI can evolve, actually, is a full name for AICE. AI definitely can evolve. That's our belief. And our security also can evolve. Thank you for listening. Thank you.